The universe is totally different from traditional knowledge, so much that what you think you know is only a small part of the truth. In fact, the information you will hear in this video is not just rare. It is the kind of truth that most people have never heard before, even those who study astronomy for years. These are not ordinary stars that simply shine and fade. These are stars that break every rule we thought the universe followed. Stars that behave like monsters, like machines, like explosions, and even like miracles. When you hear these facts, you will be shocked, because the universe is not a calm, quiet place where everything follows simple rules. It is a wild, chaotic, extreme environment where physics is pushed to the limit, where time can bend, where matter can become a diamond, and where a single star can have a magnetic field strong enough to destroy the entire Earth from millions of kilometers away. The stars we will talk about are not just unique. They are the most extreme objects in existence, each one with a quality so strange that it feels like science fiction. But the difference is that these are real. They are confirmed by science, and they exist right now somewhere in the vast universe. This video will change your view of space forever. So pay attention, because after hearing these stars, you will understand that the universe is far stranger and more dangerous than you ever imagined. The first star we will explore is the white dwarf known as Lucy, which is not just a star but a cosmic diamond. The idea sounds like a myth, like something made up for a fantasy movie. But Lucy is real, and its story is based on real physics. White dwarfs are what remain after a star like our sun runs out of fuel and collapses under its own gravity, becoming a dense core that no longer produces energy through fusion. In most cases, white dwarfs are thought of as dead stars, quiet and cooling over billions of years. But Lucy is different because its core has cooled enough for carbon atoms to crystallize, forming a giant diamond structure. In other words, the star has turned into a diamond the size of a planet. Now imagine this. The same force that compresses a star into a white dwarf is also responsible for turning its carbon into crystal. This is not like the diamonds on Earth, which are formed over millions of years under pressure deep inside the planet. In Lucy, the pressure is so intense that the entire core becomes a crystal, so dense that a teaspoon of its material would weigh millions of tons on Earth. It is not just a diamond, it is a diamond planet, an object that could be worth more than all the wealth on Earth multiplied 1,000 times, if such a thing could be measured. The shocking part is that this is not a rare concept. Scientists believe that many white dwarfs may have crystallized cores, meaning there could be billions of diamond stars in the universe, each one silently shining like a jewel in the darkness. This is a universe where the most expensive thing on Earth is just a common outcome of extreme pressure and time. But the diamond star also reveals something deeper about the universe. It shows that stars are not only sources of light and heat, but also creators of matter in forms we cannot even imagine. The same physics that makes a star burn also makes it turn into a crystal when it dies, showing that death is not the end but a transformation into a new and strange state of matter. Next, we move to a star that is so powerful that its magnetic field can destroy matter without even touching it. This is the magnetar, the strongest magnet in the universe. Magnetars are a type of neutron star, which means they are the collapsed cores of massive stars that exploded as supernovae. The difference is that magnetars have magnetic fields, trillions of times stronger than Earth's magnetic field. And this is not a small increase. It is a completely different level of power. If you were to bring a magnetar close to Earth, its magnetic field would rip the electrons away from atoms, turning everything into plasma. It would distort the shape of molecules and break chemical bonds, meaning even your body would be torn apart by the force before you could even feel heat or radiation. This is why magnetars are not just interesting. They are among the most dangerous objects in the universe. The most terrifying fact is that magnetars can release sudden bursts of gamma rays and X-rays, which can be detected from millions of light years away. In 2004, astronomers observed a magnetar burst so powerful that it affected Earth's ionosphere, even though it was tens of thousands of light years away. This means that if a magnetar were closer, its burst could be strong enough to damage satellites, destroy electronics, and even affect the atmosphere of Earth. This is not a science fiction scenario. It is a real possibility if one were to be close enough. The magnetar reminds us that the universe has forces so strong that even distance cannot protect us, and that the invisible power of magnetism can be more destructive than any explosion. But there is another shocking truth about magnetars. Their magnetic field is not constant. It decays over time, which means magnetars are like ticking time bombs, burning through their magnetic energy and releasing it in violent bursts. These bursts are so strong that they can briefly outshine the entire galaxy in gamma rays, and in some cases, they can be detected even from outside the Milky Way. This makes magnetars not only the strongest magnets, but also the loudest and most explosive stars in the universe, showing that the most dangerous things in space are not always visible. Sometimes they are invisible forces waiting to be released. Now let's talk about pulsars, which are another type of neutron star, but with a unique quality that makes them one of the most shocking objects in space. Pulsar is a rapidly spinning neutron star that emits beams of radiation from its magnetic poles. When these beams sweep across Earth, they appear as pulses of light at regular intervals, like a cosmic lighthouse. The most shocking part is not just the pulsing, but the speed of the spin. Some pulsars rotate hundreds of times per second, meaning they complete a full rotation faster than a bullet can travel from one end of a room to the other. In 2006, astronomers discovered a pulsar spinning at 716 rotations per second, which means it completes a full spin in just 1.4 milliseconds. This is faster than any machine humans have ever built, and it is only possible because the star is incredibly dense and compact. When a star collapses into a neutron star, its rotation speeds up dramatically because of conservation of angular momentum, similar to how an ice skater spins faster when they pull their arms. Now imagine this spinning object emitting beams of radiation, so precise that they act like a clock, so accurate that scientists use them to test the laws of physics under extreme conditions. Some pulsars are even used to detect gravitational waves and to study the behavior of matter under the strongest forces in the universe. Pulsars are like cosmic metronomes, measuring time with incredible accuracy and reminding us that even in death, stars can become the most precise machines in existence. But the shocking truth is that pulsars are not only fast, they are also incredibly powerful. In some cases, their beams of radiation are so strong that they can affect the space around them, creating a bubble of charged particles and radiation that travels through the galaxy. This bubble, called a pulsar wind nebula, can extend for light years and glow in X-rays and gamma rays. This means that a pulsar can be a source of light and energy long after it has died, continuing to influence its surroundings for millions of years. The pulsar is a reminder that the universe is not only about creation but also about persistence, where even the remnants of a dead star can keep shining and shaping the cosmos. The fourth star we must discuss is Betelgeuse, a red supergiant that is both beautiful and terrifying. Betelgeuse is one of the brightest stars in the sky and is located in the constellation Orion. It is a massive star nearing the end of its life, and it has expanded to a size so large that if it were placed in our solar system, it would reach beyond Jupiter. This is not an exaggeration. The size of Betelgeuse is measured by astronomers, and it is truly enormous. Think about that for a moment. Our sun is the center of the solar system, providing light and heat for Earth. But Betelgeuse is so large that it could swallow Mercury, Venus, Earth, Mars, and even Jupiter. This alone is enough to make it shocking, but the real mystery is that Betelgeuse is unstable and could explode into a supernova at any time within the next 100,000 years, which is a short period in cosmic terms. This means it could explode tomorrow, or in 50,000 years with no warning at all. When it explodes, it will become so bright that it could be visible during the day, perhaps even brighter than the moon, and its explosion would release more energy than the sun will ever produce in its entire lifetime. Betelgeuse has already surprised astronomers by dimming unexpectedly in recent years, leading people to speculate that it was about to explode. This dimming was later explained by massive ejections of dust and gas, but the fact remains that Betelgeuse is a ticking time bomb, an enormous star that is slowly running out of fuel and preparing for a final, catastrophic explosion. The idea that a star so close to Earth could explode at any moment is both terrifying and fascinating, and it makes Betelgeuse one of the most unique stars in the universe. But there is another shocking detail. Betelgeuse is not only huge, it is also unstable in its internal structure. Its core is burning. Heavy elements like carbon and oxygen, which create layers inside the star like an onion. When the core runs out of fuel, it collapses, causing the outer layers to fall inward and then explode outward in a supernova. This process is not smooth. It creates shockwaves and massive pulsations, which can make the star expand and contract dramatically. This is why Betelgeuse can dim suddenly and then brighten again, like a giant breathing creature. This makes the star not just a cosmic giant, but a living, breathing monster that could explode without warning, reminding us that the universe is not a silent place but a living system with its own rhythms and dangers. Next, we have the blue straggler, a star that cheats the rules of aging. Blue stragglers are found in star clusters, where all stars are formed at the same time. So logically, they should all age together. But blue stragglers appear younger, hotter and brighter than the other stars in their cluster, as if they have stolen youth from the universe. It is like finding a teenager in a retirement home or seeing a fresh plant grow in the middle of a desert. where nothing should grow. This mystery has puzzled astronomers for decades, until they discovered that blue stragglers are likely formed through collisions or mass transfer between stars. In a dense star cluster, stars can collide or get close, enough to steal material from each other. When one star steals mass from another, it gains fresh fuel, allowing it to burn hotter and brighter and appear younger than it should be. This means that blue stragglers are not just strange anomalies. They are evidence that stars can change their fate based on interactions with other stars. This is shocking because it suggests that stellar evolution is not always a simple, linear process. It can be influenced by the environment and relationships between stars. Blue stragglers are like cosmic rebels, refusing to age gracefully and proving that even stars can cheat death if they are given a second chance at life. But the real shock is that blue stragglers challenge our entire understanding of star clusters. Star clusters are used by astronomers to study how stars age because they are born at the same time, so any differences in brightness or temperature should be due to age. But blue stragglers show that this is not always true. Stars can change their age through interactions, meaning the cluster is not a simple timeline, but a dynamic community where stars can merge, steal, or collide. This is a powerful lesson. The universe is not only governed by individual objects, but also by relationships and interactions, where even stars can rewrite their destiny through connections with others. Now we move to one of the most violent stars in the universe, the Wolf-Rayet star. These stars are massive and extremely hot, with temperatures reaching up to 200,000 degrees Celsius, which is far hotter than the surface of the sun. They are unique because they constantly blow away their outer layers, losing mass at incredible speed. This is why they are called stars that lose their skin. Imagine a star so powerful that it strips itself apart, creating a wind of gas, moving at millions of kilometers per hour. This wind is so strong that it can shape the surrounding space, triggering new star formation in nearby clouds of gas and dust. The shocking part is that Wolf-Rayet stars are often the precursors to the most powerful explosions in the universe, known as gamma-ray bursts. These bursts are so energetic that if one occurred near Earth, it could destroy our atmosphere and wipe out life. This is not just science fiction. Gamma-ray bursts have been observed across the universe, and they are among the most powerful events ever recorded. The Wolf-Rayet star is a cosmic engine of destruction, continuously shedding mass until it reaches the end of its life in a catastrophic explosion that can outshine entire galaxies. This makes Wolf-Rayet stars not just fascinating, but also dangerous, showing that the universe can create objects that are both beautiful and deadly. But the most shocking part is that Wolf-Rayet stars are not only powerful, they are also extremely rare. They represent a very short stage in a massive star's life, meaning that we only see them for a brief moment before they explode. This makes them like cosmic fireworks that appear for a moment and then vanish in a blaze of glory. This rarity makes them even more mysterious because it means we have limited opportunities to study them, which is why each Wolf-Rayet star we observe becomes a precious window into the final moments of a massive star's life. Now let's talk about heartbeat stars, a rare and fascinating type of binary system where two stars orbit each other in a highly elliptical path. This means their distance changes drastically during their orbit, causing the gravitational force between them to rise and fall like a heartbeat as they approach each other. Gravity stretches and squeezes them, causing their brightness to increase and decrease in a rhythmic pattern. This creates a light curve that looks like a heartbeat on a monitor, which is how these stars got their name. The shocking part is not just the pattern, but the fact that we can hear the rhythm of the stars through their light. This phenomenon shows how gravity can create a cosmic dance, so precise that it mimics the biological rhythm of a living creature. It is a reminder that the universe is not just a cold, empty space, but a place where objects interact in complex and beautiful ways. Heartbeat stars also reveal that even in the vastness of space, there are systems where timing and rhythm are essential, where gravity creates a predictable pattern of motion and energy. These stars are not only rare, they are a demonstration of the incredible complexity of the universe, and how even something as simple as a heartbeat can be recreated on a cosmic scale. But the shock goes deeper, because heartbeat stars show that gravity can do more than pull objects together. It can shape their behavior, change their structure, and create a visible pattern that we can measure from millions of light years away. This means that the universe is not only about objects, but also about relationships, where gravity acts like a conductor controlling the rhythm of the stars. Next is the neutron star starquake, a phenomenon that is both terrifying and fascinating. Neutron stars are already extreme, with a mass greater than the sun compressed into a sphere only about 20 kilometers wide. But some neutron stars experience sudden shifts in their crust, known as starquakes. These crusts are not like Earth's crust. They are a solid layer of neutrons held together by incredible pressure. And when the crust cracks, it releases enormous energy in the form of gamma rays and X-rays. These bursts can be millions of times stronger than the most powerful explosions on Earth. The shock is that a starquake on a neutron star can release more energy than the sun produces in 100,000 years. In 2004, astronomers observed a magnetar starquake that emitted a burst so powerful it affected Earth's ionosphere, even though the star was tens of thousands of light years away. This shows how powerful these events can be, and how a tiny change in a neutron star's crust can produce cosmic fireworks visible across the galaxy. Starquakes remind us that even the strongest objects in the universe are not stable. They can crack, shake, and explode, just like a planet can have earthquakes. This makes neutron stars not only extreme but also unpredictable, showing that the universe can release immense power from the smallest cracks. But the most shocking truth is that neutron stars are so dense that a single teaspoon of their material would weigh billions of tons on Earth. This means that when a starquake occurs, the crust is not just cracking like a rock. It is cracking like a super dense shell that holds the weight of a mountain in every square centimeter. When this shell breaks, energy is released in a way that is impossible to imagine, creating bursts that travel across the galaxy and remind us that the universe is not only massive but also incredibly powerful in its smallest details. Now let's talk about a star that disappears without a bang, not with a supernova but with silence. This is a star that collapses directly into a black hole, known as a failed supernova or direct collapse black hole. Instead of exploding, its core collapses so quickly that the outer layers fall inward and are swallowed, leaving almost no visible explosion at all. It is as if the star simply vanishes, like someone turning off a light in the middle of a room. This is shocking because it means the universe can create a black hole without any warning, without any bright signal to tell us what happened. It also means that the number of black holes in the universe could be much larger than we think, because many may have formed silently, hidden from our telescopes. This silent death is a terrifying reminder that the universe is not always dramatic in the way we expect. Sometimes the most powerful events happen quietly, leaving only darkness behind. Next, we move to a star that is not only dying, but also destroying its own family. This is a runaway star, an object that is thrown out of its system with such force that it can carry or eject its planets. This happens when a star is part of a binary system and its companion explodes as a supernova. The explosion can send the surviving star flying through space at hundreds of kilometers per second, turning it into a runaway star. This star can carry its planets with it, or it can throw them away, leaving them to drift alone in the galaxy. This is shocking because it means planets are not always safe in their orbit. They can be violently expelled into the darkness, becoming rogue planets that wander alone without a star to orbit. This shows that the universe is not a stable place, where everything stays in order. It is a place of chaos where even entire solar systems can be torn apart and sent, drifting through space like lost ships in an endless ocean. Now let's talk about a star that behaves like a giant radio transmitter, known as a fast radio burst source, or repeating, FRB star. A fast radio burst is a powerful pulse of radio waves that last only a few milliseconds, but releases more energy than the sun produces in days or even weeks. The shocking part is that some of these bursts repeat, coming from the same location again and again, which suggests that a star or a star system is producing them continuously. This has led scientists to believe that the source could be a magnetar, or a highly active neutron star, emitting these bursts like a cosmic beacon. This is terrifying, because it means the universe can produce energy in a way that we still cannot fully understand, creating signals that travel billions of light years to reach us. It also means that the universe is filled with mysterious communication-like bursts, as if the cosmos itself is sending messages across space. This star reminds us that the universe is not silent. It is full of powerful signals that we are only beginning to decode, showing that the cosmos is far more active and alive than we ever imagined. Finally, we come to the most mysterious and shocking object of all, a star that seems to break the rules of physics itself. Dark star candidate is a star that appears too old or too strange for its environment, meaning it should not exist based on our current understanding of star formation. Scientists have found stars in certain galaxies that are older than the galaxy itself should allow, or stars with chemical compositions that suggest they formed at a time when such materials did not exist yet. This creates a cosmic paradox, forcing astronomers to rethink how stars are formed and how the universe evolved. In some cases, these stars might be the remnants of ancient galaxies swallowed by larger ones, or they might be evidence of unknown processes that can create stars under extreme conditions. The shocking part is that if these dark stars are real, it means the universe is hiding secrets that we have not yet discovered. And it may be more mysterious than we ever imagined. These stars are not just unusual, they are a challenge to science itself. A reminder that even after centuries of studying the cosmos, we still have no idea what the universe is truly capable of. But the deeper shock is that these stars could be evidence of processes that happened in the early universe, when conditions were very different from today. This means that dark stars may not only challenge our understanding of star formation, but also provide clues about the birth of the universe itself. If we can study them more, they could reveal hidden chapters of cosmic history that are still unknown to humanity. Now you know the truth. The universe is far stranger than we ever imagined, and these stars prove that reality is more shocking than fiction.